Well friends, welcome back to the presentation on regression. So today we will be looking into how to do some problems on linear regression as per your syllabus, because we had a discussion on, or we will be having a discussion on regression in details in our live classes, but here let us see how to solve some problems of regression. So before we go actually to the next step, we have an idea about regression. Regression analysis actually deals with estimating or predicting the value of a variable when we know the value of another variable or variables. So that is the situation, that we know a value of a given variable and we want to predict or estimate the value of another variable. And there are different types of regression, but here we will only concentrate on simple linear regression. And then we have a formal definition also by Professor Blair. Regression is a mathematical measure of the average relationship between two or more variables in terms of the original data. So that is the situation, and then we want to find out this regression. So here we actually concentrate, as I told, about a simple linear regression. A simple linear regression is actually expressed between two variables, out of which one is the dependent variable and another is the independent variable. Generally in a linear regression equation looks like this: y equal to a plus bx, where y is the dependent variable, this is the dependent variable, and this is the independent variable, and based on a set of values of dependent and independent variables which are available in pairs, we actually try to find out the value of a and b. Once we find the value of a and b, then we can predict the value of y given the value of x. That means suppose at the end of the calculation we find that the value of a is 3 and b is equal to 1.2, then look at this regression takes the form of y equal to 3 plus 1.2x. Now, when we know this relationship, then for a given value of x, say x is 0, I want to find out what is the value of y. Just replace 0 here, then you will get y equal to 3. Suppose you have x equal to 1 and you want to find the value of y. So, from this relation we can find it easily, and the value will be coming out to be 3 plus 1.2 into 1. So, that is actually 4.2. So, this helps us to find out. So, this is the purpose basically of regression. Simple linear regression looks like this. So a regression equation, since there are two variables involved, we can look into in two ways. Once we call y as the dependent variable and x as the independent variable, and vice versa. So this is the equation where we take x as the dependent variable and y as the independent variable. And so here we see there is a constant bxy. The notation or the value of bxy is the correlation coefficient of xy multiplied by the standard deviation of x divided by the standard deviation of y. So this will give me an equation of x on y. This equation x on y is used to predict the value of x when y is known, but not the vice versa. For vice versa we have another equation, and that is called as y on x equation. So this is your y on x equation. You see the equation is changed now. Y appears in the left side and x goes to the right side, and this coefficient also changes. Here it's bxy, but here it's byx. So when the equation is y on x, so it's byx. And look at the values of byx and bxy. You see there is slight change. Here you get regression, correlation multiplied by standard deviation of x by standard deviation of y. Here correlation is same, but now the multiplication is by standard deviation of y divided by standard deviation of x. So these two equations will be different, and this second one will be used to predict the value of y when x is given. So it's called as y on x. So these are called as regression lines, and from these regression lines we can compute the correlation also, and let us see some problems on this and see how we can solve it. Well, the first one is this. So find the coefficient of correlation, that means correlation coefficient we have to find out, and the regression line of x on y. They have asked only x on y from the following data. So some data is given to us. Summation x is 142, summation y is 166, summation xy is 2434, summation x square is 2085, summation y square is 2897, and n, that is the number of observations, is 10. Okay. So when we start this problem, first let me find out, because we'll need it. So let us find out x bar. So we'll need it later on. It's summation x by n. So always write the formula when you do the computation. And so it's 142 as you can see in the question, and divided by number of observations 10. So that is 14.2. So we have the average of x is 14.2. Now let us look at y bar. Y bar equal to summation y by n. So this is equal to 166. So 166 by 10. So this is equal to 16.6. So this is y bar. So we have x bar and y bar here. And now let us write the formula of correlation coefficient. So formula of correlation coefficient, we know that for calculation purpose the formula is given by summation xy minus n into x bar into y bar, and then under root we have under root divided by under root summation x square minus n x bar square, and then we have summation of y square minus n y bar square. So you need a calculator to do these things. See value, you see all the values are present before you. So we have summation xy as 2434, so we write 2434 minus n is 10, x bar is 14.2, y bar is 16.6, and then we have divided by under root. This is summation x square is 2085 minus 10 into x bar is your 14.2, so we have 14.2 square, and then we have here summation of y square, as you can see it's 2897 minus 10 into 16.6 square. So this is equal to 2434 minus 2357.2, that is this value. This one when you compute you will get this value, divided by we have under root. This term gives me 68.6, and the other terms give me 141.4. So when you take the square root of it in the numerator after subtraction, you get 76.8, and then this is 8.28, the first one, and the second one is 11.89. So when you do this calculation, you get this as 0.78. So this is the takeaway from here. So we have correlation xy equal to 0.78. Well, we go to the next slide. Okay. Now we have the value of r. So what we have, let us write here so that it will be easier for us to refer. So we have 0.78. X bar we had like 14.2, and y bar we had 16.6. So these three things will be requiring when you write that. Now in the question we were asked to calculate only x on y equation, not the y on x. So we'll do only x on y. So x minus x bar, let us write the equation bxy y minus y bar. You see, be careful with this, since x is appearing here, so it is bxy, not byx. Okay. Now, well, we don't have bxy, so let us compute bxy here so that we can come up simply with the value. So that is r sigma x by sigma y. Though r we know, but sigma x and sigma y we don't know. So let me compute sigma x here. So sigma x, this formula is under root 1 by n summation x square minus x bar square. So this is equal to 1 by 10 summation x square was 2085 minus x bar is 14.2, so 14.2 square. So this gives me equal to 208.5 minus 201.64, and so this is equal to, gives me 2.92. Okay, fine. So, but I need sigma y also. Well, so let me find some. Okay, let us do this here. Sigma y is equal to under root 1 by n summation y square minus y bar whole square. So this is equal to I have here 1 by 10 into summation y square is 2897 minus y bar is 16.6, so it's 16.6 square. So this gives me 289.7, and 16.6 square is 275.56, and this is equal to 14.14, and this is equal to 3.76. So now we are in a better position. We know the value of sigma x, we know the value of sigma y, we know the value of r. So we can find out 78 bxy. So this is sigma x. Sigma x is 2.92 and sigma y is 3.76. So this gives me as bxy, this gives me as 0.61. Well, now we have the equation. We come here, we write x minus this x bar is 14.2, so we have 14.2 equal to bxy, we have 0.61, and then we have y minus we have y bar, so this is 16.6. So when we do this, keep this one, let us not disturb now, and this gives me 0.61 y, and then we have minus 10.06. This is on multiplication 6.61 with 16.6. So ultimately we get x equal to 0.61 y plus 4.14. So this is the equation of x on y. So this is how we conclude this problem. So we get the equation of x on y. Similarly, we can also compute the y on x equation, but it is not asked in this particular question. So some other question might be there where it is asked. So let us look at the next question. Well, find this. So here we have raw data. So this makes our work a little bit different, but the value seems to be small and can be done. So what are we supposed to do? Find the coefficient of correlation, and the equation of regression means both x on y and y on x. Well, for this type of values, first we calculate some table, like we have to calculate x square, we have to calculate y square, and we have to calculate xy as well. So let us write these values. We have 1, 2, 3, 4, 5, well, serial, and then we have 2, 5, 3, 8, 7, fine. We require summation x, so we have summation x, this is, I'll just add up, it's 15. We have summation y, we need summation y, so just add up, you will get this, it adds up to 25. And then what x square column, just square up this, 1 square is 1, 2 square is 4, 3 square means 3 into 3, that is 9, 4 square is 4 into 4, that is 16, 5 square is 5 into 5, it's 25. And then once again 2 into 2, that is 4, 5 into 5, 25, 3 into 3, 9, 8 into 8, 64, and then 7 into 7, 49. So we require this column and this column total also. This is summation x square, and that value is 55. And this summation y square, and that value is to come up to 151. Lastly, xy column, so I multiply this, 2 into 1 is 2, 5 into 2 is 10, 3 into 3 is 9, 4 into 8 is 32, and 7 into 5 is 35. So when you add up, this is my summation xy column, and that is equal to 88. Well, meanwhile, let me calculate my x bar equal to summation x by n. So n is your 5 because you have 5 values only. 5 means 5 pairs. So summation x is 15. So that gives you 3. And then we have y bar, and that's summation y by n. So summation y is 25 and n is 5. So that gives me 5. So I have some beautiful values over here. Simple. And now, as you know that for calculating, because first you need to calculate correlation. So Rxy, let us start with summation xy minus n x bar y bar. Then under root summation x square minus n x bar square, and then summation y square minus n y bar square. So just you replace all these values now. Summation xy is 88 minus 5 into 3 into 5 divided by under root summation x square. Summation x square is 55. So 55 minus 5 into 9, and this is summation y square. Summation y square is 151. 151 minus n is 5 into, and then this is 25. Well, so when we do this computation, we see that this comes out to be 13 in the numerator. In the denominator, it is under root 10 and then under root 26. Under root 26. So ultimately, you get this as 13 divided by 3.16 into 5.09. And so that is equal to 0.81 on simplification. So this is the correlation. So we have the correlation. First part is done. Now let us go and solve the equations of x on y and y on x. For that we require sigma x and sigma y. Okay. So whatever we got, let us write here. My x bar was 3, my y bar was 5, my correlation was r equal to 0.81. Now let me compute for sigma x. Sigma x, this is equal to under root summation x square by n minus x bar square. So this is equal to n is 1 by 5 multiplied by summation x square. Summation x square we have found in the previous slide as 55 and minus your x bar is 3. So 3 square is 9. So you get under root 11 by 9, that 11 minus 9. 11 minus 9, that is equal to 2, and that is equal to 1.41. 1.41. So I calculate sigma y square, y also, sigma y is summation y square by n minus y bar square. So this is equal to 1 by 5, and summation y square was 151 minus this was y bar was 5, so you get 25 here. So you get this ultimately, you get this 30.2 minus 25. So this gives you 5.2 under root 5.2, and so ultimate value is 2.28. Now we have got sigma x, sigma y, x bar, y bar and r. So let me calculate bxy and byx. Bxy equal to r sigma x by sigma y. Remember the formula bxy, so sigma x comes at the top, equal to r. R is 0.81 into sigma x is 1.41 and sigma y is 2.28. So just to replace all these values, and then you get these as 0.5. Similarly, we have byx. Byx is equal to r into sigma y by sigma x. So that is equal to 0.81 into sigma y. So sigma y is 2.28. Just take the reverse, 1.41. So this is 1.31. So we get, now we are in a position to get the first equation, that is x on y. X on y is x minus x bar equal to bxy y minus y bar. So this is equal to x minus x bar is 3, bxy is 0.5, and then is y minus 5. So now when you simplify this, ultimately you will get x equal to 0.5 y, and then it's plus 0.5. So this is the x on y equation. Now let us get the y on x equation. Y on x. So y on x is y minus y bar equal to b yx x minus x bar. Everything is now in front of you. So y minus 5 equal to byx is 1.31 x minus x bar is 3. So when you replace all these values, you get this as y equal to 1.31 x plus 1.07. So this is the x on y equation, this is the y on x equation. So this is how we solve this particular problem. Well, now one part remains, and that is to find out the value of value of x when y equal to 6. So to find the value of x when y equal to 6, we use this equation, because x on y equation. So x we don't know, but this question mark, but y equal to 6. So we use the x on y equation. So x equal to 0.5 into, here we replace 6 plus 0.5. So this gives me 3 plus 0.5. So that is 3.5. So when y equal to 6, x is equal to 3.5. So this is one way. And then they have also asked us to find the value of y when x equal to 10. That means y is not known, y equal to question mark, and x equal to 10. Now for this we want to find the value of y. So we will not use this equation. Rather we will use the y on x equation. So ultimate equation is y equal to 1.31. Here we replace the value of x, and that is 10, and then plus 1.07. So on computation it gives me 14.17. So when x equal to 10, y equal to 14.17, and when y was 6, x was 3.5. So that is how we complete the problem. We move on to the next one. Here many things are given: x bar given, y bar given, sigma x given, sigma y given, rxy given, and we are obtain the lines of regression, okay, both, and estimate the value of x when y equal to 75. That means x is not known, y equal to 75, that is known. Then at this stage we will use the x on y equation, but before that we need to get those equations. Well, so let us first start with the x on y equation, because the correlation is already given. So x on y, so x minus x bar equal to b xy y minus y bar. Now if you look at this, we have x bar, we have y bar also, but we don't have b xy. So let us first find b xy. So b xy equal to r sigma x by sigma y. As you know, this is our expression. So r is 0.66, sigma x is 11, and sigma y is 8. So this computation gives me 0.91. So now we can use the equation: x minus x bar is 36, bxy is 0.91, and then y minus y bar is 85. So just to replace all these values here, and then we get x minus 36 equal to 0.91 y, and then we have minus 77.35. So ultimately this gives me x equal to 0.91 y minus 41.35. So this is the x on y equation. Well, and then we get the y on x equation. So that is y minus y bar b yx x minus x bar. So this is equal to y minus 85 equal to byx. Well, I have to compute byx. So byx equal to r into sigma y by sigma x. So r is 0.66, sigma y is 8 by 11. So that is, we get this value as 0.48. So we replace it here, 0.48 x minus x bar is 36. So 36. So this gives me y minus 85 plus equal to 0.48x minus 36 into 0.48 is 17.28. So ultimately we get y equal to 0.48x plus 67.72. So this is the y on x equation. Now we have to find the value of x when y equal to 75. So we will use this equation. So that gives me x equal to question mark when y equal to 75. This will get from here x equal to 0.91 into 75 minus 41.35. So that gives me equal to 26.9. So when y equal to 75, the value of x is 26.9. Okay. So move on to the next one. So next problem is quite interesting, and they have provided us with the regression lines. They have given the two regression lines, but they have not told me which one is x on y and which one is y on x. That we have to identify. So first problem is identify the lines of regression of x on y and y on x. Now for this purpose, let us start with the problem 1. Find the means of x and y. When you solve these two equations, you find a value of x and you find a value of y. Now when two regression lines are given to you, these two regression lines, x on y and y on x, actually meet at their averages. So the solution of this equation for x is actually x bar, and for y, that is the value of y bar, because they actually meet. When you solve two equations, the solution that you get is nothing but the meeting point of the two lines, and these two lines have the same meeting point. The meeting point is nothing but, in case of regression line, it is the average values of the corresponding variables. So we will solve these two equations and to find this. And once we know the lines of regression, then we can find correlation also. But first, let us identify. Without any loss of generality, let us assume that thrice x plus twice y minus 25 equal to 0 be our x on y equation. You may tell that it may not be. Yeah, it may not be also. But in that case, we will get some absurd results in terms of their correlation coefficient. So let us do and then try to find out. So since it is x on y, so I keep x in one side and take the other things in the other side. So I get this as 2x y plus 25. Sorry, 2x y plus 25. And then this gives me x equal to minus 2 by 3 y plus 25 by 3. So, well, this gives me bxy equal to minus 2/3. Okay. And so the other equation has to be y on x. So let 6x plus y minus 30 equal to 0 be our y on x equation. Okay. So here we keep y on one side and take the other things in the other side. So I get 30 minus 6x. Well, then your byx is the coefficient associated with x. So this is minus 6. So what happens? We know that there is a relationship that r square is equal to bxy into byx. And these bxy and byx, they will have the same sign. So either both will be negative, as in this case, or both will be positive. If both of them are positive, then correlation is positive. If both of them are negative, then correlation is negative. You will not get it by mathematically, because if you multiply two negative things, it will become positive. But no, if both regression coefficients are negative, then correlation is taken to be negative. So let us do this and see what result I get. So first one is minus 2/3, and then next one is minus 6. So this gives me minus 4. So R becomes equal to minus under root 4. This is a special thing we do in correlation from the regression equation. We don't put the root minus sign inside the root, because that is absurd result. And then we get minus 2. Well, not plus minus 2, but it's minus 2, because both the regression coefficients are negative. But once again, this is an absurd result, because R, the correlation coefficients range is from minus 1 to plus 1. Yeah, yes, less than equal to, or this is greater than, less than equal to. So this is the range. So this is an absurd result. That means our initial assumption was not correct. That's why when initial assumptions are not correct, you will reach to wrong results. So actually this is not x on y, rather this is y on x, and this is not y on x, rather this is x on y. So now we have our equations. Now our equations are now, let us take a new slide and do it here. So we have solved the first one, that is we had identified our equations, and we have identified that one of them is x on y and the other one is y on x. So we have identified that this is this equation 3x plus 2y minus 25, that is our y on x equation, and 6x plus y minus 30 equal to 0, that is our x on y equation. So now we go to the second part of this, that is to find the values of x and y. Well, so we go to the next slide, and here we have some space, so let us do it. So we have our equation. One of these equation is thrice x plus twice y minus 25 equal to 0, and the other equation is like 6x plus y minus 30 equal to 0. So this is the second equation. So what we do is that if I multiply my first equation, this one is the first equation, that is which is my y on x equation, by 2, then we have my y on x equation becomes 6x plus 4y minus 50 equal to 0. So this is, say, let us call it equation number 1, this is equation number 2, and this is equation number 3. So what we get is that if we subtract 3 minus 2, equation 3 minus equation 2, this gives me 6x plus 4y minus 50 equal to 0, and then minus 6x plus y minus 30 equal to 0, and when we subtract this terms gets cancelled. So ultimately you are left with thrice y minus 50 plus 30, that is minus 20 equal to 0. So you get y equal to 20 by 3, and that is 6.67. When you replace this in any one of the equations, say in equation number 1, when you replace y equal to 6.67 in 1, then we get this as thrice x plus 2 into 6.67 minus 25 equal to 0. So ultimately when you solve this, you get thrice x equal to 11.66. So ultimately you have x equal to 11.66 by 3, and that is 3.89. So what we get from this is that, so x bar, because this point, these two lines passes through the average, x bar and y bar, that is the point of intersection, is 3.89, and y bar is equal to 6.67. So this is the second part of the problem, that is we have now found out the means of x and y. Now we have to find the correlation coefficient between x and y. Well, So what we have? We have our y on x as, if you remember, y on x as thrice x plus 2ice y minus 25 equal to 0. So from here we have keep y in one side and take the other things in the other side. So I get 2ice y equal to minus thrice x plus 25, and then I get y equal to minus 3 by 2x plus 25 by 2, that is 12.5. So this gives me byx equal to minus 3 by 2. Similarly, x on y equation is the other one, that is 6x plus y minus 30 equal to 0. So you can get this as x equal to minus 1 by 6 y plus 30 by 6, that is 5. So this gives me bxy equal to minus 1 by 6. So we have r square equal to bxy into byx equal to minus 1 by 6 into minus 3 by 2. Remember, it looks like minus and minus will get cancel each other. But we will retain the minus sign because both bxy and byx are negative, indicating that the correlation will be negative. So ultimately what you get is minus 1 by 4, minus 1 by 4. So this is r square. So r will be actually minus half, not half, but on, don't put a minus sign under the root, but this is how we handle correlation and means getting regression coefficient. Both regression coefficient negative, that is correlation will be negative. So your correlation is actually minus 0.5. So this is how we actually solve this particular problem. I think you have enjoyed these few problems. Just revisit and revisit the video, and then you can solve any such problems that we have demonstrated here. Thank you so much for watching this video.